Welcome back to the lecture series on project engineering and entrepreneurship management. This is Yogesh Lange. In this video lecture, we will see one numerical is based on the critical path method. How to find critical path. So the example is draw a network diagram and determine the slack for the various events. Also find the critical path. To solve this numerical, we required one formula, and the formula is to calculate the expected time. This expected time we can calculate with the help of this below formula, which is the shortest time, which we call the optimistic, plus the 4 times the most likely time, plus longest time, which we call it is a pessimistic. So the formula is 2O plus 4 times M plus P by 6. That will give you the give the expected time to calculate. So let's see the content from this one. So this is the data which is mentioned in the given problem. So the in first column it mentioned the activity, second column it will give the description about it, the predecessor, optimistic time, pessimistic time and most likely time, and this last column it is expected time. So to calculate the expected time, we use this formula, as we have this activity, then the predecessors, optimistic, pessimistic, most likely time and expected time. So expected time we can calculate with the help of this formula, O shortest time plus 4 times most likely time plus P, that is the pessimistic, divided by 6. So the last column we can calculate that the optimistic time 9, pessimistic time 15 and most likely time 12. So once we put it the value of O from this one, the P from this one, okay, and the M from this one, then we can get the value, it is expected time, which is the 12. So from this way we have to make the data. So we have the activity, and for each activity we have to calculate what is the expected time, what is the expected time that we have to calculate. So once we calculate this for the each activity expected time, so for the B it is 9, C for D it is 10, for E it is 24, like this one. Then look the predecessors. What is the data which is most important for drawing the network diagram? It is the activity, predecessors and the expected time. Okay, so this is the description. So we know the activity name, this is the activity name A for selection of the administrative and medical staff. Okay, the predecessor for A is nil, so it dash means there is no predecessor, means this is the starting point of the project. B again the predecessor, if you see the predecessor then it is nil. So A and B doesn't have any type of the predecessors. But yes, for the C, D, E, if you see the for C, A is the predecessor, for D, P is the predecessor, for E, B is the predecessor. Similarly, if you go forward, then you see here again there is up to the K activities are given and the predecessors are mentioned. The predecessors are A, C, D, A, E, G, H. For J, for K it is F, I, G. Okay, so just remember the activity, remember which are the predecessor for that activity, and then the last column which is the expected time. So with the help of these 3 columns we have to draw a network diagram, and from that one we can calculate what is the critical path and the slack for each activity. So let's see, first we try to draw a network diagram with the help of that previous data, means from the activity, from the predecessors and the expected time. So let's start. First we write the activity A and B. Why we are taking this one? Because there is no predecessor for A, so we just join these two by a starting point. After that one we have the activity C, then we join it. Because why we join the A and C? Because the A is the predecessor for C, so as per the given table the A is the predecessor for C, that's why we join it. Similarly we draw the activity D. Now what is the which is the predecessor for D? For the D, the B is the predecessor, so we write the B After that one, the E, again for the E activity, B is the predecessor. Then next, F, which is the predecessor for the F, it is the A. And why we are writing in this way? Because as these are this is two are simultaneously carried out after completion of the B, and F and C is started when the A is completed. Similarly, I am writing the G, but G is depend on C, that's why I am taking forward one. H is also I am taking forward just because H is depend on the D. Similarly, the I activity, this I is what is the predecessor for the I? For the I, A is the predecessor, so I join the A and I. Similarly, there is I draw the J, but J is depend on the H, so I just connected this H and J with the help of the arrow. Also, J is depend on the E activity because J for the J, H and E is the predecessor, so I just join this one. Also, the J is depend on the G, that's why again I join this E and G. Okay, it means if you see here, first I join the H because J is depend on the H, predecessor for the J is H, E is also the predecessor for J, and G is also the predecessor of J. Now, as per the rules of this drawing this network diagram, we are not taking this J here because if I am taking here, then it might be somewhere there is a crossing. That's why I am taking, because J is depend on G, H, and E. So if once the E is completed, but till the J is wait for the G and H because G and H to be completed. After that one, the activity K, and the K is depend on F. That's why F and K is join. F and K is join. It is depend on I and K, so here also it is join, and also the K is depend on J. It means for the K, I, F and J are the predecessors for it. And lastly the end, because the K is the last activity, and then the project get end. So this is a network diagram. So first we have to draw this network diagram on the basis of the what are the predecessors. We are drawing that one because if you see the I, F and C, the A is predecessor, so we write in this in a sequence manner. Similarly for the for D and E, B is the predecessor, so I am writing this one. After that I move for the next activity, then again G is connected with the C, H is connected with the D, but J is depend on G, H, E, so we just connect this part, and then K activities depend on I, F and G. Okay, now with the help of this diagram we try to calculate the critical path of it. So this is the first step to draw the network the first step to solve the problem. After that one, the next it is, so we are writing this the time, expected time on the each activity. Okay, so these are the expected time to completion of the each activity, that is right. So once we draw this network diagram, then go for the next. Now this is the key. Now why this is the key? Because from this key we can calculate the critical path. We can find out what is the slack of the each activity, and also we can calculate what is the critical path. Now what is the critical path? Critical path is that which is required the maximum time to completion of the project. So let's see what is in the key. So first, how you draw the key is to be draw like that one. First you draw the rectangle, then you divide this rectangle in three parts. Okay, you just divide in three parts in horizontal, and after that one, the upper part of the rectangle, draw again. You have to make a three parts here, 1 2 3, 1 2 3. Similarly here 1 2 and 3. So this is, we call it is a key. Now in this key we have to put it certain things. What is that? Let's see. The ES. ES stands for the early started. EF, early finish. What is early start and early finish? Early start and early finish are the activity. Okay, when to start and when to close. Then the latest start and the latest finish. So these four things that you have to put it. After that one, you write here it is A, that is the name of the activity at the middle of the rectangle, and here you have to write the D. Okay, that is D stands for the duration of the completion of the activity. It means the time, and the slack. Okay, and the slack is the difference between the LS and ES. So let's see. This is the things. A is called activity. ES stands for the early start time. EF is the earliest finish. Now how to calculate ES early finish? Early finish we can calculate with the help of the formula ES plus D. What is ES? ES is this one plus D. D is the duration of time. So ES plus D, it will give equals to the EF. Similarly, LSC stands for LS is latest start time. How to calculate the latest start time? Latest start time can be calculated with the help of the LF, latest finish, minus D. D is the duration of the time. Okay, and this LF is what? Latest finish. This latest finish value we can get from the next activity. Okay, whatever be the early finish of earliest finish of that activity, that will be the latest finish of it. Okay, this is the duration or expected time, and slack can be calculated LS, latest start time minus earliest start time. Okay, so this key is very important because with the help of this key and from the graph we can have from the network diagram we can calculate this critical path. Okay, let's see, go for the next part. So with us we have the key, we write it here: the early start time, early finish time, latest finish time, latest start time, duration, activity name, and the slack. Now, so with the help of the previous network diagram, what we draw, the same network diagram we have to draw. Only what we do, we have, instead of this circle, we put it this rectangular key. Okay, we put it this rectangular key. So this is one rectangular key, activity A. This is the B because these are the previous. Okay, there is no predecessor for this two activity. Then I draw the C. Okay, here is the F. Same, whatever be the circle you draw in for A, same here you have to put it the rectangle. Okay, so we just put it the rectangle on that network diagram as it is, because that network diagram is correctly we drawn. Okay, similarly for G, for H, for J, and for K. And then once we have the same network diagram, instead of the circle, what we do, we have just put it the rectangle, and then we are connected this part. So we connect A, B with the start, then C, D, E. Okay, so we just connected this one because we should know what is the predecessors and the next activity, and that is important to know the critical path. So we just draw each and everything here. Okay, once we do this part, now the next part we have to write the D value. Okay, so we write what is the value of D. D is the duration. Okay, so with the help of the first table, that is the expected time, we are writing the D. D value is here 12. What is the value of for the B? It is 9. Okay, that is the expected time which we calculate with the help of that formula and from the last column. Okay, so that values we have to put, it is 12, 9. Similarly for the C it is 10, for D is 10, for E is 24, then the G is 35, H is 40, I is 15, J is 4, and K is 9. Means whatever be the red numbers that is shown, that is the duration of time, the expected time to completion of this particular activity. Activity A is to be completed within a, say, the 12 days. B is to be completed within a 9 days, like this one. Now once we draw this one, now we are interested to put it the value of earliest start time. Now how to earliest start time we can write here. So for the activity and B, as there is no predecessor, it means they start at 0 time, so we put it the value 0 here. So in this column 0, here also I put it 0. Okay, similarly I have to know what is the earliest finish. Now for the earliest finish, what is the formula? The formula is ES plus D, means earliest start time plus duration. So I can calculate here. This is the rectangle. Okay, so here 0 plus 12, it will be the 12. So I write it 12 here. Here also I write it 9. So simultaneously you have to first we go in a forward direction where we are calculating and writing the values of ES and EF, and then once we complete it up to this K, then we go in a reverse direction for knowing the values of ELF and LS. Okay, so this is important. Okay, so similarly we draw this one. Now for the activity say D and E, or for the activity C, which is the number. Now for the ES, C is activity earliest start. What is the earliest start for the C? For the earliest start of C, what C the predecessor? Predecessor is A. What is the earliest finish? It is a 12. That's why for the C, the earliest start time is what? Once this is finished, then only this is start. So for the earliest start time is 12. So I can make here it is 12. Okay. Similarly, if you see for the D, which is the predecessor for D? B is the predecessor. What is the earliest finish? Earliest finish is 9. It means earliest finished for this activity is 9. It means the earliest start time, it is a 9 for the D. So I write it, it is 9. Sorry, I just calculate here. C is calculated with the 12 plus 10. EF is what? It is ES plus D. So 12 plus 10, it will be the 22. Similarly, I'm calculating for the D. I'm just following the sequence A, B, C, D like that one. Okay. So here 9. So what is the earliest finish? It is 9 plus 10. It will be the 19. So I put it here 19. Similarly, I calculate for the E. Again, what is the predecessor for the E? For the E, the predecessor is B. And as I again look here, the expected finish time and expected finish time, earliest finish time, it is the 9, and that's why I take it is the 9. So 9 plus 24, it will give the EF, because the formula for the EF is what? ES plus D. So just remember that ES plus D, it will be this one. Okay. So it is 33. Similarly, I have to calculate for the F. Again, I look what is the predecessor for F. F for the predecessor A. So A is earliest finish time is 12. So I'm writing here latest start time, earliest start time for this activity is 12. Why? Again, I repeat it, because this is the expected time to complete the activity, and this will be the start only when this is completed, and this will complete it at 12, and that's why it will start at 12. Similarly, I am writing the earliest finish time, and then I have to do everything is for the each and every activity. Okay, so for this G, again I do the same thing. 22 is here, 57. Okay, for H is also I look the predecessor is 19. The earliest finish is 19. For earliest timing for finishing the D is 19. Okay, and D is the predecessor for H. That's why I'm taking this is 19 from this one. And then I just do the calculations of these two. It will give the 59. Similarly, I had to work out for the I. The A is the predecessor for I, and the earliest finish time for A is 12. That's why the earliest start time for the I is 12. And 12 plus 15, that is ES plus D, it will give the 27. Okay, now up till there is no problem, because there is only the one predecessor for the each activity. If you see, for D and E, only the one predecessor. For IFC, only the one predecessor. For the G and H is only the one predecessor. Okay, that's why we take the whatever be the earliest finish time that we have taken, that is the earliest start time for the next activity. Okay, it means for the G, I am taking this 22 here, 22. But for the J, if you see for the J, there is a G, H and E is the predecessor. And for the K, again it having the I, F and J is the predecessor. Now if you see, first we concentrate on the G. Okay, for the J, which is the predecessor, G, H and E. As per our definition, we say that the earliest start time for this activity is the previous the predecessor's activity earliest finished. Now if you see the which are the predecessors, G is the predecessor. What is the earliest time? Earliest finish time, it is 57. For H, it is 59. For E, it is 33. So here, which value I have to take? So values are different. These are the three predecessors for the activity J. Okay, and for this case, it is important that always we are taking the maximum value, because J is to be start only and only when the G, H and E is finished. It means the E is to be finished, H is to be finished, G is to be finished. If you see here, if I start at 33, means if the earliest finish for the activity E, which is the predecessor for J, if I am taking 33, is it possible for me to start at on the 33 days? Then definitely not, because this J is dependent on G and H. If G is not completed, though the E is completed on 33, but H and J is still there is time to finish it, because they require more time. It means we need to start only and only when all the threes are finished. When all three are finished, it is possible when the H is finished, because it is the highest time, 59. Here is the 57, 59 and 33 days. So I can say that it is not possible for me to start 33 on 33 days. It is not possible for me to start it on 57 days. Okay, so it will be the start only on 15th 59th day. Why? Because this is the highest time, and once this is complete means obviously this is to be this has to be completed, this has to be completed. It means only that this is remaining, and this will be the remaining, this will be the finish on the 59. So once this is finished, definitely this is also finished, this is also finished. Okay, so here I am always taking the highest value from the predecessor. So what is the highest value? Highest value is 59. So I just take it here. 59 is the earliest start for the activity J. Okay, so this is the earliest start of the J activity, and then I'm just putting the earliest finish, and it will be the 59 plus 4, it will be the 63. Similarly, if you see the K, I is there, F is there, and J is there. When the K will be start, it will be start only and only I is finished, F is finished, and J is finished. Now you see here I is finished on 27th day, F is required 22 days to complete, but it is not possible for me to start the K activity on the 22 or 27, because again there is a J activities to be completed, and this is to be completed only on 63 days. It means I have to wait for up to the this to complete, and then I have to start the K. It means though these are early, very early finished before the even in a half time, but till we are not start this K, because we are waiting for the activity J to be complete, because it is required much more days. It is around 63 days to require to completion of this J. Okay, though the duration is 4, but yes, because this J is depend on other activity, that's why it is to be completed on the 63th day. So I'm taking the earliest start for the K. It is a 63, highest value from the predecessor. Okay, and then I calculate the earliest finished, it is 72. Now this is a forward direction. We fill up all the upper rectangles. Okay, so ES value, D and EF is to be finished. Now we are interested to know the value of ALF, ELS. Now for that one we go in the reverse direction. Okay, so this is the forward cases when we are calculating the earliest start and earliest finish, and for the latest finish and latest start we have to go in a reverse direction. Okay, now what is the reverse direction? The first reverse direction you see here, what is the latest finish? Now as K is the end point, there is no other activity after that one, so I am taking the EF value here, and that the EF value is 72. So latest finish is what? It is 72. Now what is the latest start? As per the calculation, latest start we can say it is the ELF value minus D. It means ELF value minus D, it will give the ELS. So 72 minus 9, it will give you a 63. So I'm writing this is 63. Then you see here this K, for the K, I, F and J is the predecessor. It means for the I, for the F and for the J, which is the latest finish? Latest finish is the latest start of the front activity. Which is the front activity? The K activity is the forward activity. Okay, it means for the J, which is the predecessor is the value of LF is 63, because latest finish it will be the 63. It means latest finish, latest start is the value of latest finish of the forward activity. So here I'm taking 63. Similarly you see here, so 63 minus 4, it will be the 59. Similarly for I, again I put it the value of LF is 63 from here. Okay, from this point, because latest finish of this I activity is the latest finish of the K activity, because I is the predecessor for K and K is the forward activity of the I. Then again I calculate 63 minus 15, it will be the 48. Similarly I am taking f from here, 63 value, 63 here, okay, and then I found, again I calculate it, and once I calculate that part, 63 minus 10, it will be the 53. So 63 minus 10, it will 53. Okay, now again go in a back direction, again to calculate the, as the G, H and E is the predecessor for J. Now here for the E, what I have to take, as this is the earliest start, it means the earliest finish for E is how much? It is 59. So I just take it. For the G it is 59, see here it is 59. Okay, 59 plus 35, it will give 24. Similarly I had to calculate for the H. For the H, obviously the earliest finished, latest finished is the latest start of this activity, and H is the predecessor for J, that's why I'm taking this value here. So I write 59. Similarly for, again I have to calculate 59 minus 40, it will be the 19, and similarly I have to calculate for the activity E2. Okay, for D is calculate, for E is calculate. Okay, now up till there is no problem because we go in a reverse direction and only the one activity is there, forward activity. For the G, H and E, only the one activity is forward. Just like when we are going in a forward direction, that's why we have the predecessor is only the one, there is no problem. But when there is a predecessor is 1, 2, 3, then we taking the maximum value from it, okay, to know the earliest start of it. Similarly, now if you see for the B, for the B activity, there is a D and E are the forward activity. It means for D and E, P is the predecessor. Now which is the value here? The latest finish. Now if you see here, the latest finish, here is the latest start of the D is 9 and latest start of the E is 35. Now from these two, which one you have to choose? Now as we go in a forward direction, that's why we choose the maximum value. In this case, again in a reverse. As we go in a reverse direction, so here we choose the minimum value. Okay, now what is the minimum value from this one? As the B have the two forward activity, D and E. So from D and E, we have choose the minimum value, and here the minimum value is 9. That's why we take the LF value is 9, and then 9 minus 9, that will give the LS, that is 0. Similarly, if we see for the A, now the for A, I, F and C are the forwarded activity. Now from this one, I have to choose which is the minimum. Okay, and the minimum is value I got, LS value, minimum LS value is 14. So I just take it here, it is 14, and then I 14 minus 12, it will be the 2. Now up till there is no problem. So once we go in a forward direction to calculate the value of ES and EF, and to calculate the LF and LS, we go in a reverse direction. One is the forward direction, one is the reverse direction. Now how to calculate the slack? The slack can be calculated. Now you see here only the one square box is remaining, and that we need to fill up, and from that one we can get the value of the critical path and the slack. The slack can be calculated with the, as it is the formula is LS minus ES. So here LS minus ES, what is the value? It is 2. 2 minus 0 is 2. For the B, 0 minus 0 is 0. Again we have to calculate for C. It will be 14 minus 12, it is 2. Then for the D, 9 minus 9, it is 0, because we are minusing the LS minus ES. Okay, so LS minus ES, it is 0. Similarly for the E, 35 minus 9, it is 26. Then for the F, it is 53 minus 12, it is 41. So similarly we have to calculate the slack. Slack can be calculated with the help of the formula, that is LS minus ES. So you see here everywhere we have to, in the green color shade, that the numbers are mentioned, and we have to minus this LS minus ES, and we got this value. Okay, so now we just fill up this one with the help of the formula and calculate the slack. Now you see here the slack for the activity A is 2, for I is 36, for F is 41, for C is 2, for B is 0, for G is 2, like that one, so on. Now how to find the critical path? If you observe properly, then you see the B slack is 0, D is 0, for H is 0, for J is 0, and for K is 0. And if you see here, there is some number. Okay, it is not 0. Now we join those activity whose slack is 0, and that will give you the critical path. So first start, I join it to the B, then I join B and D because the slack of B and slack of D is 0. Similarly, I join the H as the slack of D and H is 0. Similarly, I have to join the J, which is the slack is 0, and I join the J and K where the slack of K and J is 0, and then it's a N. Now what is the critical path? Whatever this solid sphere which is shown, this is the critical path. Okay, this is the critical path. Why? Because the slack value is 0. Now why we say this is a critical path? Because you see here, this is to be activity we have to monitor properly, we have to control properly, because if there is a delay in this activity, then there will be the chances of delaying the project. Just like you know that the activity J is depend on the G, H and E. Now I have to more focus on the H because J to be start only when the H is finished. And you see here the G is 57 and E is 33. It means if this E activity get delayed by some 2 days, 5 days, then there is no problem because this J is not impacting by the E, but mostly the J is suffering by H. If the H is delayed by 1 day, then there is a chances of delay in this way. Similarly for the D, if you see here again the D is very important for H, is to be completed. Similarly for the B is again it is very important. So this is we call a maximum time required to completion of the project, and we have to continuously monitoring these activities. So this is a critical path. So you just show it, the B, D, H, J and K are the critical path. Okay, thank you.